So today, let's answer the simple question: how do we build our Angular application offline ready, but not only Angular, because what we learned today is totally applicable to any other framework or to frameworkless apps, vanilla JavaScript apps, to pretty much everything. My name is Maxim. I came to you from Oslo. I run similar meetup in Oslo, Angular Oslo meetup. So we are soulmates with dear organizers. It's my great pleasure to be here. Also, I run like lots of other meetups and a couple of conferences. One of them is NG Vikings. This is why you see this funny photo of me. So if you already bought ticket to NG Vikings, this great job, dear organizers. If you didn't buy it and you don't know how to get a 20% discount, then bad job, dear organizers. So yes, we work on every community, every Angular JavaScript front-end community can get decent discount to get to this conference. We are by developers, for developers. We are not professional organizers. We do our best to create something cool. So like we don't care about profit, etc. We are registered as non-profit. But still, we have to earn some money to bring speakers, to deliver good venue. You are very welcome. It's end of May in Copenhagen, Denmark. This is my Twitter, webmaxru. This could be useful for you to follow me because I will share this slide deck right after my session. It's totally online. Plus, what I tweet about, mainly I tweet about all the news about Angular, about front-end in general, about progressive web apps, of course, and just as a couple of examples of tweet you might see there, and at the same time some latest news about progressive web apps and say modern web in general. Yeah, so I'll try not to put my shadow there, but yes, so my Twitter is webmaxru. What we have here, some great news about new APIs. So soon we'll have full access to file system in our JavaScript application, which is quite scary in terms of security, but still this is a natural step. We want to totally fill the gap between native apps we can build and possibilities of web platform. So the API is under development. So this is not implementation yet under development, but API itself. It's quite challenging, to implement something secure. Next, good news from Apple. It's quite, very limited stream of the news about service workers and PWAs from that company, and some say releases bring something new, some releases bring regressions, but the last one was pretty optimistic. So they continue their work on service worker API. They fixed lots of nasty bugs. So now you can implement more or less production-ready stuff for iOS. And the funny thing, they never call this concept PWA for some reason. I don't know why. They call it websites saved to the home screen. So I introduced a new acronym, WSH. So if you see something like this, then you know what it's all about, right, in reality. And the last one I want to share with you is about another great APIs coming to web. It's about setting triggers for, I don't know, some future events. For now, we are talking about time triggers. So basically, you can implement something like alarm app on, for example, Android system. Mainly, it all starts from Android, like Sandbox to play with this API. Again, there is a design doc of this API is available. We are not talking about implementation of this API yet, but still the progress is clearly visible. We really want to have our web applications as powerful as native ones on any device without any wrappers, because web platform is cool, right? Before we dive deep into Angular and Workbox, just a brief reminder what is PWA at all. And important notice, I'm here not to promote and evangelize about PWA. This will take too much time, so let's pretend that you want to build this up, that I don't have to convince you, right? So you heard about PWA from here, from there. Now it's time to really try this. In a couple of words, what is PWA? This is just the way we build our web products. I don't want to overuse web apps because not every web product is what we call application, right? So we can easily reason about regular websites, and they benefit from adding some features from Service Worker API also. So it's not limited to SPAs only. So we built our web products using modern APIs exposed by evergreen browsers. Why? To deliver the best possible experience for our users. So it's for them and for us. These apps will work everywhere, right? So it's good for us. One code runs everywhere, and no need for any kind of cross-compilation, wrappers, whatever. JavaScript is native, of course, for the browsers themselves, so it's obvious, right? But also for the operating systems. Of course, having full-scale API is impossible without support, direct support from operating system side. Then we can tell that, yes, our JavaScript code is native for this system. Cool. I stopped to give this compatibility tables where that works because it works everywhere now. Not everything, but everywhere. So let's have it like this. We are at Angular meetup, and this is Angular user group, right? So what's about Angular support? Obviously, Angular, like any other modern framework, is embracing this idea, and we can create a progressive web app in many ways. First, we can do everything by hands. It's totally possible. It's JavaScript code after all. Then we can use the tools exposed by Angular team called Angular Service Worker, and I have just a couple of slides about this, just to give a quick overview. Or use some other tooling, and this is not a secret. Today we are talking about Workbox. I think I can safely say that this is kind of industry standard at the moment. It's obviously the most popular way to build PWA for any framework, as I mentioned. Before we say how to do this, let's architect a bit, and let's think what will it take to create a minimum viable PWA, like MVP PWA. So what should we add to our regular website to even call this a progressive one? First, we have to provide web app manifest, but it's not so much about development here. This is basically a JSON file following web app manifest standard, which is giving your app name and set of icons, some brand colors. So today we are not about this. Application shell. This is way more interesting because it will take some efforts from us if we want to create it by hands and create it in a proper way. And next to things, I think and I hope that we make our products like this just by default, right? So it's not about PWA at all. This is just a good manner for the web. Let's have our apps responsive and served over HTTPS. But if you comply with these four options, you can safely call your application a progressive one. So today we focus, or at least we start from the application shell, and let's continue our architecting session. So let's imagine we have an application, and I have this like mobile layout just to save some space. So do not be like biased by thinking that PWA is something only for mobile web. No, totally, it's for everywhere. So first, we have to understand which resources we exactly need to have in the app shell. App shell, this is, say, it's not part of PWA ideas. This is, say, architecture of one of the possible approach. How do we build our apps? Pretty simple when we think about our application itself, like set of resources like JavaScript, HTML, CSS, maybe some images, as some limited set of resources we have to fetch from the web and give to the browser to display our UI. So something meaningful, not just like loading indicator. Just imagine that you take your mobile device and you open any application there, like Facebook, and you don't care at the time are you connected to the network or not. You always know that at least UI will be loaded. And let's have same idea. Let's apply the same idea for our web apps, and now it's totally possible. So we pick the resources, assets, files, you name it, we need. Then we don't want to always have the same version cached forever and served forever, right? So we have to provide some kind of versioning, and the best way for us to differentiate between version 1 and version 2 is to have some hash sums. Then we will exactly know that something was changed. So we have to calculate these hashes. Then it was on the build time. Then on the runtime, we have to put these assets into cache, and this is very specific cache. It's not the old gold HTTP cache. This is like relatively new one, but it exists in all the browsers, called cache storage. It's a very specific type of storage. It's designed specifically to cache requests and responses. So it's very specific cache. So we have to put these assets, right? And on all the next loads, we just have to, instead of going to network, we go to cache and give these files to the browser, right? And this way, we actually provide offline support because we don't care about network anymore. About versioning, we have to do some extra checks, of course, on every load, right? Not to have the stale version. So we have to provide some logic about fetching new versions, comparing, and all that stuff. Why? Because if the version was updated, we have to, of course, update the cache, right? And then on the next load, this is why I have this n+1 load, we can serve updated one. At the moment when we served immediately something from the cache, but we already know that there is a new version available, of course, it would be cool to have some message to our user, because maybe they want to update, maybe not. If, for example, if they fill some long form and they got this message after a few seconds, maybe they don't care. They just want to complete what they do. So technically, we can force reload this immediately, but please don't do this. Just give a message. We can split all the tasks into 3 chapters, right? First, it's something we do on build. Second, it's about runtime, and actually it's service worker which is responsible for all this complex logic. And third, this is formally not a part of this PWA checklist we had earlier, but still this is really good practice, I'd say best practice. So why not to implement this as well? So 1, 2, 3. Let's have a look. What will this take to implement everything manually? Just to understand why do we need these extra tools, extra automation, extra help after all, at all, right? Super brief. I think this will be like the shortest introduction to service worker APIs ever. So what is this at all? This is JavaScript code in form of JavaScript file or files, so we can implement some structure. Formally, this is worker, one kind of workers we have on the web, and this is event-driven one. Let's keep this in mind. We can think about service worker like about some kind of gate, which is responsible for managing all the outgoing requests, HTTP or to be precise, HTTPS requests from our app to any external place like our API, external API, CDN, whatever. So using service worker, we can give any kind of responses to any kind of requests. Furthermore, our service worker can react on some external events from the network. And maybe you can tell me what kind of events do we get from the network which we can catch by our service worker, even when our app is not running at all, even when the browser is closed. So, right, it's push notifications. Magic of service worker is that it's kind of always on duty, and compared to our application, which can be loaded or can be not loaded. And this is like crucial difference, for example, from WebSockets. This is very, very interesting. So if we think about our app and the browser operating system as home, then service worker is kind of janitor. Good. Now we know how to do this logically, right? So let's have a look how we code it. And of course, let's start from this application shell. Very, very schematic understanding of how that works. You remember that service worker is event-driven worker. So basically, all the code we have inside is wrapped into some kind of event. Then install one of these events. This is a good place to actually put everything into cache using cache storage API. Good. Next event is activate. When our service worker actually takes control, service worker has quite interesting and to some form sophisticated life cycle. It's taking control of the page not right after it was fetched and loaded and installed, if you didn't provide some shortcuts. This is why we have this specific event called activate. And this is good time for us to clean the previous cache, because we don't want to have all the versions on the user's machine, right? Looks not very complex, right? But in the real world, we have to deal with lots of, say, side effects, lots of edge cases. And after all, we have to deal with quite specific parts of HTTP protocol, because work with the network is not the simplest part, right? And cache invalidation is also not the trivial work to do. We have to think about many things. Okay, just imagine we implemented everything. Now we have our cache populated, and we manage this in some form. Now it's time to intercept the requests, because how this offline works. Service worker, you remember, it's kind of gate. It sees that our application loaded into the browser, requested some resource like, I don't know, main.css, and our logic inside service worker should say, hey, instead of going to the network, go to the cache storage and check if this main CSS there. If there, then serve it from cache. If not there, go to network and serve it from there, and at the same time put it into the cache. So it's like logic fallbacks, logic fallbacks. In a big picture, it could look something like this. So we check what is the URL, because we can provide totally different logic, like really different logic for different kind of resources. For example, for API, we can always go for network. For the application shell, most likely we can try our luck with the cache if maybe it's already populated. Again, this is very naive code, of course. In the real world, you will find many challenges. Starting from, you have to implement some kind of routing anyway, if you want to have the flexible like a system to manage your PWA, you have to implement different strategies, not only cache first or network first. For example, stale while revalidate. What does it mean? This means that on this strategy, we try to serve something from cache, but at the same time, right after we served this, we still go to network to check if the new version appeared. If yes, we update this version in cache to serve this for the next time fresh. Yes, implementing service worker manually, I promise this is very interesting work, and I promise it's very time-demanding work, and I promise this is very error-prone work. PWA, this is progressive, right? So think about progressive in that acronym, like exclusively about one utility thing. It's about progressive enhancement. So our goal is to improve our app if possible. But it might happen that you write service worker in the way when you not improve your app, but you put your app to complete offline. And it's quite challenging to say reset all your work, because once registered, service worker will try to control your page until the end. Yeah, there were some cases when some big sites were offline just because some, I don't know, specification of service worker or fetch API, some internals related to security was updated, but service worker was not ready. So what do we have after all? Great flexibility. We are here to implement everything we want. At the same time, great responsibility. We luckily can rely on some tooling. And let's say that these 3 points are applicable to any external library, module, package we use, right? So we don't want to implement some complex stuff because we have to focus on our work. At the same time, since almost everything is open source, we can always go to check the source code to understand how that works, and this will make us better developers. I really recommend you to do this. But the last 2 points are especially applicable to service worker and related APIs because it's a living standard. As I mentioned, some things, like some critical stuff related to security could be updated. And you have to, of course, update your code, or you have to rely on creators of this or that library. Plus, there are lots of edge cases related to, for example, lots of details in HTTP implementation. So what kind of tooling do we have? As I already mentioned, just a couple of words about the native one from Angular team called Angular Service Worker, or NGSW. It contains, say, good for start amount of functionality for you. So application shell, some possibilities to do runtime caching and managing push notifications. And it's all about automation. Since this is, say, native to Angular library, it knows everything about your application, right? And it uses all the tools we have in Angular. So for scaffolding, we use schematics. For build, we use CLI in special mode, and to run, to provide all this runtime stuff, we are here to use the service worker itself. So we don't write a service worker by hand. We use the one supplied by Angular team. To just briefly illustrate scaffold, just one-liner. We apply schematics called Angular PWA, and in the same schematics, why it's called PWA but not service worker, because in addition we receive some default manifest file as a bonus for us. On the build time, in the special mode, Angular CLI will build the configuration file for a service worker for you, so you don't have to do anything. And on runtime, we have this file called NGSW worker, which is actually service worker, written by Angular team for us, so we don't touch this. Summary, NGSW, really easy to start, integrates with Angular without any problems, so it will work like for 90% of the projects, really out of the box, after just one liner. If you want to tune this somehow, there is a JSON file with configuration. If you need to code something, there are some moments you might want to tune. You use Angular style of coding, so observables, dependency injection, so all we know and love. I'd call this approach add and configure and get what's included after all. So it's not extendable at all. It's pros and cons. So this is really good for starting, and maybe for regular projects it will be enough. If not, I recommend you to start using Workbox. What is Workbox? First, the amount of functionality we get out of the box is really, say, impressive. We have pretty much all we can imagine and all that could ever be automated from the current set of service worker APIs. But the main and the really killer feature is that we can still have our own service worker. So we have full control on this code, on this file or set of files. We extend it by adding some features. And how to do this? Let's start. First, there are three main working modes of Workbox: CLI, Webpack, or Node module. What do we prefer for Angular? What are your thoughts? Let's just start thinking loud. Workbox CLI. Well, it's quite trendy that every small library has its own CLI at the moment. Before appearing ngx command, it was total hell, right? So your global scope polluted by like dozens of these CLIs, and it's totally non-CI/CD friendly. npx solved partially the problem, but still, like any CLI has some limitations, right? So what's included in CLI will work in CLI, not more, right? Maybe this is not the best option. Webpack. Do we have Webpack configuration file exposed in like regular Angular application? No, we have to eject this, right? And then we will lose all the power of Angular CLI. So we got this Webpack configuration, but we cannot use Angular CLI anymore. Maybe not the best deal also. So Node module, let's give it a try. There is a special one called Workbox build, and we can safely use it to developer dependencies. We use this on build time. We build our service worker using this module. Plus, it installs as dependencies all the other modules of Workbox. Let's keep this in mind. This will useful for us on like one of the last slides. And Workbox is really modular. It's not a monolithic app. It really like split across, I don't know, maybe 10, 12 different files. Of course, this is really great because it gives us full flexibility, and we can have we can load really what we want, right? We don't have to load all this massive library. Okay, Node module. Let's have a look at the sample build script we could have. So you remember, our goal is to first define, on the build time, we have to define somehow the set of resources we want to pre-cache in our application shell, and we have to build the list of these resources plus their hash, so to manage versions in service worker later. On this code, very schematic, we use inject manifest method from Workbox build. We have some kind of configuration, and we inject manifest, let's say for now, inject something to somewhere. Good. Let's have a look on configuration. What is this exactly? The key options there is glob patterns. This is how we actually say to Workbox build what exact files contain our application shell. And we are quite flexible here in specifying these resources. We can provide like full names, some patterns, so it's totally fine. Another important option here is source, where we inject this. So you remember that in Workbox, we manage and maintain and write our own service worker. So this is why we have our source service worker. So what we inject and so now we know where to inject, right? And what to inject, what this Workbox build does. It does something like this. Basically, this is a JavaScript object with the name of the asset based on this pattern and its hash. So what we do, we take service worker, source one, and we just do file operation. So we inject this array to this file, and we are then done with ready to go service worker. How this source one could look then? So first, we have to fetch the library of Workbox itself. The simplest option is to get it from CDN. We'll have a look at different options a bit later. And then we have a really magic method called precache and route. And we inject this manifest you've seen on the previous slide exactly here. Instead of this empty array, Workbox build just opens this file and put this array with resources and their hashes here. And this is pretty much what it does. And the rest of the magic of this caching, serving, checking, validating, updating cache, and all the rest is up to this precache and route method. This is why I call this like pure magic one. So what we have to do in our Angular configuration, we just have to add one more command to actually execute the file we just have seen after our build. So in our distribution folder, we have ready to go Angular build, and then we process this by Workbox build to get ready to go service worker. Good, so this is how we totally solve our application shell need. So then after we open the app, Workbox will precache what it needs. And if you go to offline or if you shut down the server, at least the application shell will be ready, or always ready for your users. But let's continue our discussion about how do we update this. There is one well-known compromise or trade-off in PWA, not PWA, but application shell architecture. So you remember that we try to serve the app shell, these resources, from cache immediately without going to the network. This is why we have a behavior like this. With the first version, it's totally fine. We deploy this. We got this in the browser, so displayed version number 1. So obviously, we got it from the network, right? Service worker is not taking control yet. But now it has the control and it has everything pre-cached. Just imagine that we updated our app, fixed some bug. We hit refresh, what we see? We still see old version. Why? Because this is nature of service worker, not service worker, but application shell architecture. It tries to immediately serve this from cache. You got crazy, say, speed and the performance of displaying something just because we don't ever go to the network. But we have this trade-off. If we implemented everything correctly in our manual service worker, or we use Workbox or NGSW, on the next refresh or on the next opening of your app, you will, after all, see version number 2, right? What we can do here is to show some message to the user. Again, this is not obligatory part of PWA checklist, but still it's good to have. And I bet many of you have seen similar message on a variety of websites. So who have seen something like this? Yes, for me this is maybe the worst thing in I don't know, PWA universe. Despite it says that your app is always fresh, it's not really. But yes, we have to find some compromise here, right? And if you see this message, what does it mean? It means that that first, this is service worker-driven origin. Also, it means that you visited this website, this web app, some time before. And third, that means that the version of this website was updated between your visits. So this is like obligatory criteria to see this message. Good. So what does Workbox expose for us to say catch this moment in our application? Two options are available. First, we can use plugin called Broadcast Update. Workbox consists of different modules and different plugins we can use in these modules. And there is variety of like built-in plugins, and we can write our own plugins. So this is as flexible as possible. So you remember this pre-caching module, which is also containing this magic pre-cached route method. It also contains this add plugins, and basically we add this line, app shell. This is a name of the channel we organize between our service worker and our app. It can be whatever you want. And in our app, we use this broadcast channel API, which is available in a majority of the browsers, and listen to this. And once we have something, we know that it's time to show this message. Okay, good. But we can do even better. So what this plugin does, it checks the set of resources we have in application shell, but it doesn't care about service worker file itself. So if we added some more logic to the service worker, we still can think that this is a new version of our application, because it can change the behavior of our web product dramatically. So how to deal with this update? We also want to show something. If something else except application shell set of resources was updated, then we can yes, and this you still remember, this is option number 3 we have in our imaginary application shell architecture. Option number 2, we can follow service worker lifecycle. It's as you remember, I told that this is quite interesting, and if you have some free time, of course, it's really cool to go through all these steps service worker goes in its life. But if you want your task to be done, and then you can dive deep into documentation later, you can use helpers. And how the service worker registration code is looking like the very default one, but still containing some best practices. So this is as say generic code as possible, not related to Angular, Workbox, whatever. This is just how we say in our application bundle that we want to register this file with service worker against this. We check the feature itself, so it's important because, I don't know, not every browser supports this. Like we still have some old browsers, and we still have Internet Explorer, which will never support this. Yes, so just to avoid some red lines in our application log, we have to do this. And next, we wrap this registration into onload listener. Why do we do this? You remember, we are about progressive enhancement, and it's totally fine to postpone the registration and all the stuff related to service worker to as late moment as possible, not to compete with main thread of the browser for network resources, for CPU resources. So service worker is something that we can, I don't know, screw up with and fail with. It should not affect our application load. So let's list some requirements we'd love to have in this registration flow. Feature detection, we have this. Postponing of the registration. In my sample, this is just onload, but framework-wise, it's even better to have it after UI was rendered totally, because it takes some CPU power, right, to execute this JavaScript, to draw these buttons, inputs, whatever. And then we can hook into some lifecycle events of service worker to understand that service worker was updated, okay. And in most cases, if we update service worker, that means, if we know that like this physical file of service worker was updated, it means that application was also updated, right? I mean, there is no app update without service worker file update. Why? Because we inject the manifest with hash sums into this file. So this is totally trigger for us. This is where Workbox window module helps us. This is exclusively in version 4, which was released 2 days ago. So this is as fresh content as possible. As I tweeted, most likely this session is the first ever public session about Workbox 4. So yes, Workbox window, this is the first module in Workbox family of modules, which is related not to service worker, but to our application. We use this in our app. Why do we do this? To have nice way to register this and nice way to hook into these events without like diving too deep to exploration of service worker API. So we install this, and then in our Angular code we can go for this code. And this is the proper moment for us to actually register service worker. This is resolve of Bootstrap module method, and this is the best place where we inject the registration code, because it happens after UI is ready, right? So we use Workbox object from Workbox window and register method of this. In the middle, we attach some listeners. They are on my next slide. We basically need this one. It's called installed. And we have to add one more condition. We have to listen to isUpdate property of the event. Why? Because installed fired both for totally fresh service worker and updated service worker. So this point number 3, where we have this message, should go there. Otherwise, it's totally optional, but some sites show some message that service worker, they don't say about service worker, they say that like this website is ready to work offline, something like this. It's like totally optional. But here it's important, really important, to have 2 other helpers in our service worker called skip waiting and client's claim. Otherwise, we stuck with old service worker even after every refresh of this tab, as many refreshes as we want, we still see old version because of specifics of service worker lifecycle. So don't forget to add these 2 methods into your service worker code. This is totally must have. This was very brief intro to Workbox window. Couple of days ago, it actually was a couple of hours before the official release, I posted this blog post. Why? Because I collaborate with creators of Workbox, I contribute, so I know some things in advance. So this is why I was ready to blog about this, and all the details about this flow you can get here. So as you remember, I will post the link to this slide deck. It will be always under your fingers. Good. So we are totally fine with application shell. Now runtime caching. We go really fast through this section because it's quite simple to implement, because Workbox folks, they did great job by simplification of this process, like as much as possible at all. So in our service worker, what we do, we register some routes. Again, the registration of the route is pretty flexible. Here I use regexp, and we say let's all the routes like this will have network first strategy. Cool. Another sample, let's all the routes like this will have cache first strategy, plus we can add variety of plugins to fine-grain control every single piece of the functionality. There is a great set of strategies, 5 of them for any live case, plus a great set of plugins, and you can always write your own. But we have a brief look on background sync, which is really interesting functionality. And again, it's quite challenging to implement it by hands. You have to learn lots of different APIs to do this. But in Workbox, you achieve this like with a couple of lines, not even the code, but of the configuration. What is this about? It's about postponing some events happened in our application during offline until the app goes online. So just the best use case is you have some, I don't know, messenger, and you are offline and you put some message, you hit send, and instead of server not found, you receive a message. Your message will be delivered when you go back to online, and you can close this app, you can close this browser. This will be delivered, say, by the properties of, by the, I don't know, APIs of operating system. So how to do this? We use another plugin. We just provide name of the queue. In my sample, this is about sending tweets, and we give some configuration like try during 24 hours. If not, then just never mind. And the same idea, we register route, and here we provide a method in addition, so it will react only post methods, and basically that's it. So we give it's applicable to network only, and our plugin, which we just introduced earlier. That's as easy as this. If you go to implement this manually, believe me, this is interesting, but will take lots of time, and you will learn many different things about APIs, about how to work with IndexedDB, how to implement queues. Interesting, but time-consuming. Next, push notifications is totally out of scope of the Workbox. Workbox is all about network automation, but you remember that we still have control on our own service worker, so why don't to use this possibility? We can always add the handlers we need to do push notifications manually, and this way we have as flexible logic as we need. So this is how we react on push event from the like outside network. Okay, this is code to show the notification itself, and then we can provide any logic for what happens on the click on this notification, what happens when we close this notification. It will take some, I don't know, time to code this manually, but it's full flexibility. Next moment, you remember that I introduced the simplest use case for the Workbox when we loaded from CDN. I don't know how that's applicable to production mode, but it's totally useless for our local development when we offline ourselves, right? So this is not very good to rely on Google CDN. How to have everything locally? Another method from Workbox build called copy libraries. So we create another JavaScript module for Node. So this is not for the browser, this is for Node. This is more or less one-time runner. We need it only once for every like new version of Workbox. So once we run this code, we got folder libraries with all Workbox modules inside. Okay, and then don't forget in your Angular configuration file to actually put this folder to assets, part of your configuration for Angular CLI, actually copy all the modules in Workbox, and then inside our service worker, instead of going to CDN, we can refer to the local one. So the first line says take this Workbox SW file from the library, and the second line says that take all the rest of modules from local, otherwise it still go to CDN. And what's exactly this Workbox SW? This is basically like wrapper over all Workbox libraries to create this global Workbox object, and to make sure that it loads only the packages we need. So this is okay option, but we still can do better. What's wrong with this configuration? So we still have to deploy all Workbox libraries, even those we don't use. We will not load them, it's okay, but still we have to deploy this. This will be a separate folder inside our application distribution, and the service worker file itself will be like as is, not minified, not processed. How can we fix this? Bundling. It's also something really new. It also came in Workbox 4. And basically, I created these slides this morning. So I tried this morning. We can implement bundling for our service worker file exactly the way we do it for the rest of our application. And all the bundlers are for our service. So then the code inside our service worker will look like, say, the code of modern JavaScript application, right? So we do some imports, and documentation very explicitly says how to find this particular method in like this particular module, so you will not get any problems. You see that we got rid of this global Workbox object. We use only methods we want to use. But most likely, not all the browsers will understand this ES6, I believe, imports, right? This is why we still have to do some bundling. Rollup, Webpack, Parcel, whatever you want. In my experiments, I used Rollup. And the configuration is could look something like this. So we need some plugins a bit later about this. And we say, take this as input file, like the same file will be as output one, just process this. But the idea is in this plugins. Let's have a quick look what we need here. First, resolve. It's just to gather all these imports from the proper location. So this is purely utility stuff. Then replace, and this is must-have, because in Workbox modules, in their source files, which we take in this case when we use bundling, there are lots of places where we have a condition. If the process end node env equals production, then we do some, say, extensive logging. So you will see lots of like log lines. So we have to replace this variable to actually string called production. And then terser, we do tree shaking because this condition will never be true, so it will just get rid of all this code, and our bundle will be quite small. So this is very important. And who can tell me, terser? It's a new name of what quite popular plugin? Yes, please. Yes, Uglify.js is no longer supported. Someone forked this, and now it's under under name terser. This is why instead of this very long, in terms of timing, when we build our app, and it always stacks on like 92% Uglify.js, now it says 92% terser. So this is just a new name of old stuff. Basically, that's it. And then we just add the rollup script to package.json. You see, I use npx, so I don't like global CLIs. Resulting service worker will look awful for us. Don't pay too much attention to this. It's just minified, uglified, bundled code. It's exactly what browsers love, like very small bundle, which easy to fetch, easy to parse, easy to run. Good. So let's give a summary after all. Workbox. It's framework agnostic. So everything you heard, like except some like very specific stuff, where to put the service worker registration, is applicable to absolutely any framework or without framework. Rich functionality out of the box. Very configurable. If you need to run your own code in form of plugin or in form of event listener, you are welcome to do this. But some steps needed to configure this. This is why it's set up configure and code if you need. But as a result, you get exactly what you want, not something that was predefined for you. You'll find more detailed sample code on this GitHub repo. It's again very fresh on this particular branch, Workbox v4 bundle. So it's about bundling and everything. And I invite you to join PWA Slack I run. We are almost 2,000 developers there. It's open Slack team. We discuss all the stuff about PWAs, and folks from Workbox, from all the browsers and other libraries are there. On that, thank you very much.